Good morning, afternoon, depending on where we are here. Just hang on. I am just setting up here this morning. Okay, so today is September 7th in Vanguard here. This is day 2. I just have to start up a few things like the blackboard and so forth. I moved my visual picture a little bit here. Maybe in the top left it'll be better. We'll see. Just so it's not in the way as much. So we're just starting notebook, and what we're going to look at today, we'll get to, this is day 2 of Pre-Cal 30, and we're going to review special triangles in the first part of the videos today. I'm going to make 2 videos for today. The first one's just going to be a review of special triangles first. Okay, so let's put down our objectives here. We'll hide this little thing here, and we'll set this up. The funny thing is, guys, every time I try to retype something and have something open before I start Screencastify on this computer, it doesn't seem to want to boot up very well. So I'm just going to put that beside the picture. Okay, so today is September 7th. This is Pre-Cal 30. And this is day 2 in the first unit. Okay, so if you're not on the same pace as Vanguard here, which might be possible because eventually I'm going to have to make the videos during my classes instead of before them, in the sense that right now it's okay because I'm not doing very much volleyball or anything like that, but I'm going to get fairly busy here in the next little while. But right now I'm just making them before the classes. So this is day 2, and this is video 1 for today. And this is going to be a review of special triangles. We need special triangles in this unit here. We're going to be looking at the unit circle here. That'll be the beginning of my next video, depending how long it takes. I'm just going to check and see the time here to make sure I don't go too long on the video. So what we're going to be doing is looking at the unit circle, and we need to know those special triangle relationships. So what I'm going to do today is just look at the special triangle relationships to start with. Okay, so let's look at, if we take and I draw a tool, use a tool here to draw a square. And I'll make it fairly big here. Let's start here. Yeah, there we go. So if we've got a square and we cut this square in half, with a diagonal, either way, I'm just going to go this way. We get 2 special triangles. Well, 1 special triangle, but 2 of them. Okay, and we look at this as being, if I change to my marker here, there it is. Okay, I'm just going to set my there we go. Okay, so this is a 90-degree angle, obviously, for the squares. And if we assume that each of these lengths of legs, 1 and 1 here, 1 and 1, because they're square. Well, if we do Pythagorean theorem, leg squared plus the other leg squared equals the hypotenuse squared. So 1 squared plus 1 squared. So 1 plus 1 equals r squared, or whatever, or if you want to call it y squared, or z squared, or whatever you called it for Pythagorean theorem, or c squared. But it equals this side squared. So that's 2 equals that squared. So if we take the root of 2, it's just root 2. And these are 45-degree angles. So that's our first special triangle. And we have 45, 1, or 1, 1, and root 2 for side length ratios. And we have 45, 45, 90 angles. And that'll be important. If we look at our each of these angles here, like this one at the bottom. We'll look at the one on the bottom here. And we're looking at the trig ratios. So if we look at the trig ratios of 45, okay, sine is equal to opposite over hypotenuse, so that's 1 over root 2. And we know that we have to rationalize that from pre-cal 20. So to rationalize it, go root 2 times root 2. So this is going to be root 2 over 2. Okay, similarly, cosine 45. Okay, cosine is adjacent, so the adjacent side would be this one over root 2. So it's the same answer for that in this case. And then if we rationalize that, root 2 over 2. Oop, root 2 over 2, not root 2 over root 2. Fix that up. Root 2 over 2. Okay, so that gets us our special triangle relationship for sine, cosine. And if we do tangent, that's opposite over adjacent, 1 over 1, which is equal to 1. So that gives us the relationship of sine, cosine, and tangent for 45 degrees. Okay, 90 degrees. Okay, if we do 90 degrees, we could do 90 degrees, but that's on the quadrilateral angle anyway when we do quadrants. So we'll talk about that when we do the unit circle. Okay, so now let's do the next special triangle. If we have an equilateral triangle, we can cut it and get that 30, 60, 90 degree triangle. Okay, so we'll do that underneath here. So we'll move this up. Okay, it's important to know these relationships. Sine 45 is that, cos 45 is that, tan 45 is that. Okay, we'll do the next ones here. So if I draw another picture here, of a equilateral triangle, so we'll use this kind here. Okay, I'm going to try to make them all equal sides. I'm going to guess about there. Okay, now if we take this and split this in half, so we'll take our line tool and do a perpendicular here. Okay. Oops, that's a little crooked. Let me do that again. Okay, so this is going to give us here. Now, if this is an equilateral triangle, okay, so this is 60 degrees, this is 60 degrees, and that top angle is 60 degrees, split in half. So then we can say that these are both 30 each. And this is 90 down here. Okay, let's look at only one of these. Okay, we're interested in the 30, 60, 90 triangle. Now, if these were equilateral triangles all the way around, like that, if we say that each of these sides is 2, so that when we cut this one in half, that we can say this is 1. So this full side's 2, 2, and 2. We can say that's 2. Well, this would be half of it because we've done the perpendicular bisector of this angle, and so this is half of 2, and this is half of 2. Half of 2 is 1. So now, if we're trying to figure out what this side is, we can use Pythagorean theorem. Oops, I got the picture in the way a little bit there. Let me move this down a little bit. There we go. Sorry about that, guys. So 30. So we've got the bisector in here. We're looking at this right triangle only of the 30, 60, 90 degrees. So this would be the hypotenuse here. So this side squared plus this side squared equals 2 squared. So let's call this one y, this one x, and this one r. So if we're doing that one, y squared plus x squared equals r squared. So y squared is unknown, x squared is 1 squared, and this is 2 squared. So y squared plus 1 equals 4, So we've got to subtract the ones. Okay, so we get y equals root 3. So this is root 3 here. So there we have 30, 60, 90 triangle. So across from the 60 degrees is root 3, across from the 30 degrees is 1, and across from the 90 degrees is 2. Okay, so then we can look at the sine of, let's look at 30 degrees and the cos of 30 degrees and the tan of 30 degrees. Okay, now the other thing I can mention here is these can be changed into radians as well. Okay, so if you're looking at what that means, remember that 180 degrees is pi radians. So then if we're looking at 30 degrees is 1/6 of 180. So it would be pi divided by 6 for radians. If we're looking at 45, well, how many times does 45 go into 180? 4 times. So it'd be pi over 4. How many times does 60 go into 180? 3 times. So it'd be pi over 3 and so forth. So you could use the radian measure, and we'll put those in as well as we're going here. So, oops, sorry about that. Okay, so sine is of 30. So 30, we'll use this triangle on this side here that we got marked. 30 is up here. So sine is opposite over hypotenuse, 1 over 2. Okay, don't even have to rationalize that one, a half. Cosine of 30 is adjacent over hypotenuse, root 3 over 2. And tangent is opposite over adjacent, 1 over root 3. So that one we have to rationalize. So if we multiply by root 3 over root 3, we get root 3 over 3, sorry. So that's the sine and cosine and tangent of 30 degrees. And our final thing here is sine 60, cos 60, and tan 60. Okay, so if we look at those, we're going to look at this angle here. So sine is opposite over hypotenuse, root 3 over 2. So you notice that what the cos used to be there. Cosine here is adjacent over hypotenuse, 1/2. Okay, I squish those together. I'm going to spread them a little bit here so they're not so squished together. So cosine 60 is the 1/2 this time. And tangent, let's see what tangent is. Tangent of 60 is opposite over adjacent, root 3 over 1. So it's a little different. Root 3 over 1 is just root 3. Okay, and that is all the tan ratios of the two special triangles. Okay, and that's as far as we need to go, except I'm going to go back here and just remind you that if we put, and we'll do a different color here, if we were doing radians, 45 degrees in radians is pi over 4. So if we were doing radians, it would be pi over 4, because 45 goes into 180 4 times. And remember that 180 degrees is pi radians. Okay, if we do that with 30, 30 goes into it 6 times, so this is pi over 6 radians. You can convert using the ratio if you want, but if you just know 30 goes into 186 times, that works too. Okay, and then this one here would be pi over 3. It's twice the size of this one. Twice the size of pi over 6 is pi over 3. So those are the radian measures. So the blue ones are radian measure, and the black ones are the degree measure. Okay, so we'll stop the video there. That's the first part of the video, and we're still going to work a little bit today. We're going to start out with the unit circle, so that'll be in the second video. I just don't want to make a pile of videos that are really, really long. So I'm going to stop the video here as soon as I can find the right button here. Okay, so I'll stop it and we'll get back to the unit circle in the next video for day 2.